back with team number 13. A very exciting team. Recently represent the University of Texas at Tyler in one of the largest canoe and kayaks events in the state of Texas. Proud to introduce number 13 group, Flexible Outboard System. Team, are you guys ready?
Yes, sir.
Go ahead.
Good morning. Thanks for being here with us today as we display our senior design project. We are Group 13. My name is Darren McKinday.
I'm Glazar Ahmed.
I'm Jeffrey Neighbors.
I am Nanwin, and now Darren is going to introduce you guys to our project.
Ladies and gentlemen, we introduce to you the Flexible Outboard System. The following footage was from earlier this month at Demo Day Spring 2019, which is an annual event sponsored by our project sponsor, Austin Canoe and Kayak, out in Lake Conroe. This is an annual event where different vendors and manufacturers of canoes and kayaks come out to showcase their newest products and merchandise out to the public. And this was our first time debuting our system to the public. The Flexible Outboard System is a lightweight, compact system that's designed to be an add-on attachment to a variety of canoes and kayaks. This system literally transforms a manually powered canoe or kayak into a motorized, user-friendly, self-propelled, high-tech boating system. Our system features a simple control panel that's user-friendly and increases stability, maneuverability, and adds power to your boat and vessel of choice. Every project starts with a why. And we decided to do our project after witnessing the devastation Hurricane Harvey had on our local community and surrounding areas in the fall of 2017. We decided to develop a quick assembly system for first responders to enable them to quickly assemble, easily operate, and rescue victims from floodwaters.
As you can see right here, this is Jeff and I simulate the rescue mission.
After getting our project sponsored by Austin Canoe and Kayak, our project focus shifted into the outdoor water sports world. After consulting with industry experts, we discovered there was a growing need in the fishing industry for flexibility with fishing vessels. And now Glazar will go into further details about our project research.
Thank you, Darren. The market for our project is North America, and we decided to target this market for its clear reasons. As you can see on the left, the number of vessels, canoes, kayaks, and pedal boards in the U.S. goes from 316,000 to 416,000 in the last 14 years. The North American states were the ones most highlighted, as you can see on the right of the slide, and Texas and Florida were the two among the top sellers in this business. Here are a few solutions available in the market for this kind of rescue missions. If you want to convert your manual boats or any other vessels into motorized boats, here are a few of the two solutions available in the market. If you're looking for more stability or flotation, here are the two outrigger kits available in the market, but as you can see in these diagrams, all of these kits or systems require you to do some kind of hard fits or permanent installs to your vessels. Our flexible outboard system does not require you to do any permanent installs. It can be easily attached and detached in any canoe, kayak, or a paddleboard. Going forward in our initial prototype, this is how we attach an aluminum bar to our canoe using sandwich compression method to hold on to the bar, and we had some attachments to the bar. We designed our hand controls for the motor dials to control the two motors, one on each end. We also designed a rudder system with a rudder hand control attached to the aluminum bar to control the motion of the vessel. And here's how we attach our pontoons for more stability. We had a PVC clamp holding on to the two pontoons with long PVC pipes for height adjustments. Now Nan will go through the preliminary design.
As you can see right here, this is our prototype exploded view drawing without pontoons and motors. Is included 52 components in total. And this is our overall view for the first finished initial prototype. We started with 30-inch thrust trolling motor with 30-pound thrust trolling motors with 30-inch shaft available commercial on the market and having good reputation. We attach two pontoons, one on each side of the main control. This pontoon offers stability for a user when they do a fishing activity. It's also good for amateur fishermen or young children who may not feel comfortable on board for the first time. And right here, as you can see, we have one piece aluminum bar. For the next evolution, we plan to make it extendable. The pontoon will be extendable, and then the whole aluminum bar will be collapsible and adjustable. It could be better for shipping, packing, and transportation purposes. And we do have the rudder right here for the prototype, but after testing, we came to realize that we can control the direction of the boat by manipulating the power output of the motor on each side. And right here, we have our final design, and now Jeff is going to go through what we did to improve and upgrade our system.
So here's a final exploded view of our final system. It consists of 213 total components. Now, as Darren mentioned earlier, our initial project was to create a disaster relief system. And the way we did that was we added 2 aluminum metal sheet bars on our system that could be used for picking up stranded people like in the video we showed, or transporting food or water to people that are stranded. This photo shows, the photo on the left is our photo of our system being retracted inwards. This is how you would transport it, say, from your garage to the lake. The photo on the right is how you would use it in the water, extracted. Right here it is extracted, and on the other side it is retracted. When it is in its retracted state, it is 59 inches long, and when it is extracted, it is 79 inches long. This is how we connect to any kayak or paddleboard with a railing system. It's a simple L bracket that just latches right in with wing nuts and it holds it down. It does not make any permanent mounts to the kayak or paddleboard. This photo shows how we connect to a canoe. Any canoe with a gun rail on a canoe is a lip that goes around the top of a canoe, and there's a wood bar that we have that goes underneath the gun rail, and then we have a bolt that comes from the top of our system, and it basically creates a compression method. This shows the evolution of our hand controls. The one on the left is a picture of how we started with our prototype, and then we looked into 3D printing and we printed a control box that shows our speeds going forward and backwards, and we also added light switches for our front and back lights. And inside our control box there is a battery for the front and back lights. This was our upgrade to our pontoon attachment. We needed something that was more rigid and more stable so that there wouldn't be any veering in the water. When we did our prototype, we were losing direction from the pontoons opening up or closing up, which was decreasing speed and altering direction. This photo right here shows our motor mounts, which are connected right here. They're very versatile. You can put an electric trolling motor on there, a gas trolling motor, and in some cases even an outboard, a smaller outboard motor. In any boating vessel that you have that has a motor on it, you need to have navigation lights. So we installed lights on the front and the back. If you're sitting inside the boat, the one on the left side is your port side, which is a red light. The one on the right is a starboard light, which is green, and your back light is your stern light, which is white. We also added a few attachments. We added a fishing net holder, a boat cleat to tie off, a drink holder for a cold drink, a fishing rod holder, end caps for all of our metal bars and motor mounts. This photo shows just the versatility of our system. It's connected to a canoe right there. The middle photo shows a picture of it connected to a native kayak. In this case, we brought a new canoe kayak and it is connected to, and the photo on the right shows it connected to a paddleboard. Now I'm going to show you video of our testing. As Nan and Darren both mentioned earlier, we found that we could manipulate our motors in turn, and without the rudder, we can almost achieve a 90-degree turn in the water just by manipulating the motors.
Wow. And as you can see right here, this is Jeff on the new canoe testings on the lake. And there's another footage of the same new canoe right here. And we have a 13-year-old user testing our system on demo day, and she was really happy about that and really comfortable when she on board. you can see right here is me and Wizard on board, and both of us fitting and still stable. Jeff on the canoe, and this is on the native kayak. And that's how we lift up the motor. We're also testing on the paddleboard right here, have Jeff and Wizard, and they both really stable and comfortable on board. We simulate our system, and now Wizard is going to go over our FEA.
Thank you, Nan. So we ran our FEA analysis on the flexible outboard system with the assumptions of a 250-pound person sitting inside the vessel, depending on your canoe or kayak or a paddleboard. We have a 44.54 battery that we use for the system, and a 0.05 psi pressure acting from the water. We have Jeff in the picture as he was our model for this system, but we're assuming a 250-pound person for the simulation. Here is our simulation shown in the diagram. Our safety factor comes up to be 4.29 for this system. Considering we'll be out there in the water trying to rescue someone, supply foods and goods, or for fishing purposes, it is a very good safety factor within the range. Now Nan will go through the economic feasibility.
As you can see right here, this is our total cost for building the prototype and mass production. Adding up component costs, manufacturing costs, and marketing costs, it will cost us about $17,652. We do not know the retail price just yet. However, we do know that if we want to produce 1,000 units, it will cost about $964 per unit.
Now Darren will conclude this presentation.
Thanks, Kosar. The mass capacity of our system is equal to the mass capacity of your boat and vessel of choice. The runtime for our system is completely dependent on the application. For fishing activities, we recommend a smaller scale battery, as you see to the left, which has 230 cold cranking amps. For a disaster relief system, we recommend a large scale battery, which has 1,000 cold cranking amps. The fishing activity battery will give you a runtime between 30 to 45 minutes. The marine size battery will give you a runtime between 1 hour to 2 hours. The maximum speed of our system is also completely dependent on the application. The max speed the trolling motor offers is 5 miles per hour, but depending on which vessel you choose, a canoe is generally lighter than a kayak, so a canoe will move faster in the water than a kayak. And now we're going to hear from industry experts we had the pleasure of interviewing during our time at Demo Days.
This is Bill Bracken with Yak Gear Railways back corner panels. Had a chance to really look at what the guys have done. Absolutely amazing. Really can see where it helps quite a bit as far as stability. Hopefully we'll have the opportunity as Yak Gear to work with them a little bit and add some more accessories. They've done a really amazing job. I know it took a lot of time and effort, and look forward to really working with them. It's a great idea, and hopefully we can help get a little bit further.
I have Kevin on here with Kayak, manufacturer of fishing kayaks. I got to check out these students here, engineer students, right? Their project they're making, it looks pretty cool for disaster relief. Nice project, they've done a good job. Guys have done a good job, and they keep on working on it.
Incredible. There's a bunch of manufacturers that are here, and they're shocked that these kids came up with this in a short time. And you know what? They did it so quickly and so fast, and they didn't have to work too hard to figure things out because it was just right there. Right? And kudos to these kids. Okay? I'm Bill from Racing Cave. See you guys later.
Thanks for your time and attention. Now we're going to open the floors up for questions.
Yes, sir. Those at the end were paid actors.
So I weigh well over 250 pounds. Do I need to have any concerns about using your system?
Yes,
Well,
sir.
our safety factor, as you saw, it was 4.29, which means all the forces that we put into the system, considering plus times 4.29, so you should be pretty good. We also demonstrated, it was me and Nan riding in the vessel. We were pretty good.
Yeah, and we also, we didn't include it here, but we do tests with 3 of us. So all of us were fitting on the new canoe, and it's still stable, but it's a little bit slow the system a little bit.
It's
So
kinda
it's
slow,
like
you
quite
push it.
slow, but the system is still really stable.
So did we learn from your FEA analysis? Does it tell me about stability? It looked like in your FEA analysis you're assuming point masses that are symmetric on the item. Is this correct? Go back to your FEA analysis.
Okay.
Does that make sense? So I'm looking for a quantification of stability of some sort, right? Because that's kind of your overall goal. And you've done symmetric FEA analysis. Did you do any asymmetric FEA analysis? Because when the person's getting on or you're rescuing, isn't that going to be off center?
Yes, sir. We did run it, and there is some in our paperwork. We do not have any in this presentation. The safety factor did vary. It did go down a little bit, like in the situation in the video you saw where I rescued Nan, the safety factor did go down, but I believe it was still above 2.15. I'm not exactly sure on that number, but I'm thinking it was 2.15.
And how are you quantifying stability for your, like if you were going to manufacture this, you would have a specification sheet. How do you quantify stability? Are you going to do it through a moment, through torque, through forces?
This would be mostly all the forces that are acting on the actual system, which is mostly just the pontoons and the two dual motors you see on the back, and also the lightweight attachments that are not pretty negligible at this point.
Any other questions?
A wonderful presentation. The interview to kind of testimony, whatever your beautiful design, right? Did you get some sales order already?
Actually, we had
the first guy in the presentation, he actually offered us to meet with him after we done with this presentation. So yeah.
And also Kevin Hawkins from CACU also would like to work with us. He presented an idea to us that said he actually has a manufacturing facility in China that can actually replicate all our products on all our parts, and he would be glad and delighted to work with us.
Yeah, our main thing that we would like to do is get these manufactured by ourselves, and as he stated, Kevin Hawkins, he suggested to us that we could roto-mold it for a fairly reasonable price. It was out of our budget for this semester, but at a reasonable price that was a lot cheaper than injection molding.
And that will definitely bring down our manufacturing costs per unit.
So this is the one engineering model I have seen so far, very close to the commercialization. Congratulations.
Thank you,
sir.
Thank you.
Yes, sir.
Yeah, so for the economic feasibility, the $934 or something, that was for the attachment, right? That's not including the canoe?
No, not the canoe.
No, that's just the
not
canoe.
It's just our system. Yeah.
Yeah, we're not selling canoes here. Yes, sir.
Yes, I agree. This is the closest to commercialization, so you did a very nice job in actually surveying what a customer would think and want, even down to the level of a cold drink. So
Yes, sir. Thank you.
kudos for that. I have some technical questions for you, and they're on the form of comments, not questions.
Yeah.
So if you don't have an answer, it's okay, because it could be something to explore. Aluminum. Why? How does it perform in water, salt water, fresh water, weather? Other types of material testing. Have you explored any of that? If not, that's a possibility to look into. So I don't want an answer on this one. But you have multiple types of material in there. Now, if you reduce the amount of material, the variation, you reduce your manufacturing cost, but you have to go with what would take your weather conditions. Stability, I like that question, because one of the things you could do is look at the industry. How do they quantify their systems? The problem with finite element analysis, every team said finite element analysis and gave us general safety factor, but really, that doesn't work here alone. If I load that boat in a disaster relief situation with food and water on one side and a human on the other side, and suddenly something falls, you have a completely unstable, asymmetric, nothing that is as the assumptions are working in your analysis. Plus, you're in fluid, where your inertia plays differently. So your first Newton law, second Newton law, all change. Plus, you have tests shown, but I'm not sure, have you had any chance to test in rough weather? In something where there is really conditions where things are up and down and the waves are playing with it? Probably not. Probably not so safe to do that. So the finite element analysis is not the right tool here. And if it's going to give you just what we call an initial view of, okay, probably the cantilever kind of setup is not going to break if I push on it with so much load and so on. General safety factor is not the right. So explore industry standards. when I buy something like this, what is it that they quantify their stability with? So that's something to look into. And the third thing is, I will dovetail from questions from my colleague there always about market study. If you compare, yes, everybody's amazed about it, and that's a good thing. And you are ready to market. You want to also see how your competition is marketing theirs and what are they looking at. Obviously, we've done a lot of work in there, but is anybody competing with me? Is this patentable? At least copyrighted? At least can I get some rights out of it? And how far different am I from others and their price point? Because that's the back record. So I'll leave it as the comments. I don't want an answer, but things to think about as you go along.
Thank you. Thank you. Thank you.
Any other question? I will have a final comment to say, and it has to do with stability as well, because your whole idea started with disaster relief,
Yes.
and the fact that the current kayaks and the current canoes fail on disaster relief due to the instability. Right now, you are increasing the overturning moment capacity of your vessel just by widening it out, the support. If you look, closely, I will say that you guys have increased maybe 300% the lifting capacity without overturning the. So those are things, those are comments from market point of view, from the structural point of view, that are really important to bring into the eyes of everybody, because it's a significant increase, and that's why you actually have the floaters. So very good presentation. Thank you very much, Group 13.
All right, anybody who wants to help us with this, come on.
Where's the rights? Let's take up the sponsor.